Hello everyone, I am Santosh Kumar, Technical Lead in AI at HCLTech, Colorado, USA. Thank you for joining my session, Deploying Privacy Preserving Generative AI from Edge to Enterprises at the Applied AI Summit 2025. Generative AI is rapidly transforming how enterprises operate, automating content creations, optimizing decisions, and driving personalization at a scale. But with this progress comes a critical challenge. How do we deploy these powerful models responsibly, especially in sectors like healthcare or finance, where privacy, compliance, and data security are non negotiable? In this session, I'll walk through a practical and scalable approach to deploying privacy preserving generative AI across both edge and enterprise environments. So, challenge in generative AI deployment, data sensitivity in healthcare, manufacturing, finance. So, we'll talk into this. So, let's first explore some of the real world challenges enterprises face when trying to adopt generative AI. First, data sensitivity. So, medical records, financial data, and industrial telemetry often cannot be centralized due to regulations or IP protection. Second, latency and compute limitations on each devices. How do we run a transformer model on a teeny embedded system or remote hospital node? Third, the risk of data leakage during centralized model training. Even anonymized data can sometimes be reverse engineered. Lastly, organizational silos and lack of end-to-end ML ops pipeline often prevent scalable and secure AI deployment. Third, privacy preserving architecture overview. So, to address this challenge, we propose a modular and scalable architectures for privacy preserving generative AI. It starts at the edge, data is processed and learned locally using federated learning agents. Model updates are sent to central server, but no raw data ever leaves the edge. A differential privacy layer adds mathematically bound noise to prevent identity interface from updates. Secure aggregation using encryption techniques like homomorphic encryptions or SMPC ensure updates are never exposed. The architecture is modular, designed to support healthcare, industrial IoT, and enterprises deployment from low latency edge environments to cloud native applications. The fourth, federated learning plus differential. privacy. So let's zoom in on the two pillars of our architectures. So federated learning and differential privacy. Federated learning enables collaborative training without moving data. Means each edge device or node trains locally and share only model weights. But model weights alone can leak sensitive information. That's where differential privacy comes in. It injects noise into gradients or model updates to ensure that no single user's data can be reverse engineered. So this combo delivers a strong privacy utility balance. It allows large language models to adapt at the edge while learning securely across and enterprises. Next, we can see the real world use case healthcare AI. Let me illustrate this with a real world example from healthcare. It deploy a federated generative AI system across multiple clients to summarize EHR for doctors. Each customer's data trained locally on its node and only encrypted updates were shared. The result 30% faster clinical decisions, full HIPAA compliance, and improved doctor trust thanks to explainable outputs. SAP visualizations provided transparency into each summary right on the device. We are now adapting these same systems to some other customers and client where IP sensitive inspections image must remain local. Next, we have explainability and compliance. Explainability is like vital, especially when deploying AI in regulated industries. We which SAP attention heat maps and line to generate local explanations for predictions, showing doctors or operators exactly why the AI made a decision. Each model is documented with model cards, lineage reports, and differential privacy settings. This builds trust and also ensures traceability during audits, turning black box generative AI into a transparent and governable system. We also enable audit friendly dashboards that provide visual drill downs into model decisions, training data influence, and data minimizations protocols. These features not only meet regulatory expectations like GDPR, HIPAA, or ISO, but also empower internal teams to conduct these assessments with confidence. Future outlooks and final takeaway from this we can see looking forward we see rapid growth in multimodal generative AI combining vision, text and structured data securely across silos. AI governance will evolve with real time policy enforcement where model self regulate based on the context. The key message I hope you take away today is this: generative AI can be powerful, scalable, and secure when privacy is embedded into its foundation. Thank you for joining me. I look forward to the live questions and future collaborations. Thank you.